All right, let's continue. So, looks like we got four tech questions. Let's have a look here. So, you probably noticed I've kind of, I've tried using Maxima, but I just keep gravitating back towards Derive 6. I know it's old, but it's just so easy to use. It has a lot of features in it, and it's such a small program. It's only like 10 megabytes, and it just works so well. I think TI did a really good job with it. So, anyways, let's see what's first now. Evaluate the derivative and graph the function and the tangent line. Okay, so our function is 2x cubed plus 3x minus x squared, and the derivative, and then sub in 2, and then we want to graph the function, and then the tangent line. Now, there's a way to graph the tangent line as well, but I'm not sure if I remember how to do it. Is it possibly this? That's not working. Let's just have it. It's not quite online that I want, is it? Search, not implemented yet. Tangent. Y x 0. Oh, I probably have to put in fx. Yeah. Ah, that did not do it. Tangent y x 0 simplifies to the line tangent. Result will be a variable in x. Oh, okay, there we go. It did work. I just have to, okay. There we go. That's tangent at 2. All right, that worked perfectly fine. Now the next one, I'll just have to change this to 1 over x. Oh, there it is. 1 over x minus x squared. I think that was it. And then a is 1. Okay, so let's, I don't know. Okay. Derivative. And then a is 1. Then we want the tangent of fx when x is 1. Okay. There's the tangent line. And there is the curve. So, interesting tangent line at 1. Okay. Next one now. X squared minus x power 12 plus 3x plus 2. And then this time we want the derivative at 0. And then we also want the tangent line. At 0. Yeah, that's it there. Okay. Okay, good. Good. And the last one of these 4. One over x minus x power 2/3. Then we want x is minus 1. Okay, and we'll graph and we'll tangent. And what was the point? Minus 1. Oh, I should calculate. Oh, huh? What's going wrong here? No tangent at minus 1. 1 over x minus x power 2/3. Oh, it's imaginary at minus 1 because the graph doesn't go into the minus. So that's kind of weird. That's kind of weird that they would give that question. But they have done that before where they've given a question where it doesn't have an answer. It's because you get it. No, why is there a problem here if you put in minus 1? Because the cube root of minus 1. No, why is it doing that? It's interesting now. Why is it not? Why is it defaulting to this now? Is this some complex number nuance that I'm not fully grasping right now? I'm gonna cheat a little bit. Just see what happens. No, I've crashed it. I didn't mean F. I meant absolute. I should have typed in abs, not fabs. Ah, now it's stuck because it's recursive now. F is in the definition for F. I'm gonna have to kill this process. All right, it's killing time. Okay, we killed it. All right. It's a good question. I feel like it's something with the graphing program rather than the question. F of x equals 1 over x minus x squared and then cube root. Okay. Okay. Okay, it's done a little bit better that time by separating out the 2 and the 3. So I wonder what the program is doing. Cube root of x squared. I wonder what will happen if I swap it around the other way. So if I say x squared of the cube root. Ah, that's a weird quirk in the program. Okay. Okay, interesting. Okay. Oops. Okay, yeah, there you go. There it is at -1. Interesting question. And what's a real shame is that it's an even question, so I won't have the answer at the back. That's a real shame. It's a real shame because this is, of the 4 of them, this is the one I'd love to see. That's a pity. That's a real pity. I wonder, I'm not sure how to do derivatives in maxima yet. I haven't looked that up. Give it a try, see what happens. The name of it. WX. Let's give it a try. We've got calculus here. Let's give it a try. Okay, 1 over x. 1 over x minus x power 2/3. Okay. And then calculus differentiate fx. Let's see what happens. Okay. Okay, is that the same answer? 1 over x squared. And it's a little bit different here, but let me just go back to the original. And then differentiate it. See how it compares. Okay. Okay, so the derivative's the same. And let's see its graph. I think I do it like this, isn't it? Oh, I think I don't need the y in here. Yeah. Okay. So this is a first. This is where I don't think this is. Okay, I guess I've learned a valuable lesson today. There isn't exactly one perfect program. As great as Derive is, it actually struggled a bit with the power 2/3 when it comes to graphing. Um, Weirdly, it seems to prefer the imaginary root when you cube root -1, which is quite interesting. What does Maxima prefer to do? Give all 3, perhaps? No, it prefers -1. That's fascinating. That's really, really fascinating. I'll have to remember this quirk in the future. Yes, okay. Very, very interesting. That's really, really interesting. Let's compare that with maxima. Really interesting. Okay, I've actually quite enjoyed that little diversion. I think I've learned something valuable about derive and maxima, and I won't be so quick to poo-poo maxima in future. So this is personally quite informative video today. So anyways, I think that actually would be a good point to wrap it up. I hope you found that useful. Thanks for watching. Any problems, please let me know, and I'll see you next time.